All right, in this next portion of lesson 2 in unit 6, we're going to look at some other rational functions. So the ones we had in the previous lesson were all constant over x minus something, and then h, and then plus k on the outside. So sometimes we're going to have a linear function for a numerator and a linear function for a denominator. Or, and we'll look at some other stuff as we get in the next lesson, but there might be a few like this in lesson 2 yet. So as I look at something like this, where there's an x in the numerator and the denominator, a couple things about that. Let's take a look at this example to kind of walk you through it. So y equals 8x plus 3 over 2x minus 6. A couple important things about this. Before I do anything, I'm going to think about what the vertical asymptote would be. Well, the vertical asymptote is going to occur wherever the denominator equals 0. Okay, because I can't divide by 0, so I'm not going to plug in that number, whatever it is. So if I think about 2x minus 6 equaling 0, and I think to myself, well, what could I possibly plug in for x that would make that equal 0? Well, if I use a little algebra, I add 6, and then I divide by 2, I'm going to end up with x equals 3. So that tells me if I plug in 3, this function's in trouble, because 3 times 2 is 6, and 6 minus 6 is 0, and I can't divide by 0. So my vertical asymptote is going to occur at x equals 3. And that means that my domain of this function is going to be all real numbers or x values that don't equal 3. Okay, it's just another way to write that same thing. Then what I'm going to do is I'm going to use that info. I'm going to draw a vertical asymptote with a dotted or slash dash line at x equals 3. Okay, I can't plug that number in. Now, the next thing I'm going to think about is the horizontal asymptote. The horizontal asymptote normally was, at this plus k business from the previous examples, but there's no plus k here. So now the horizontal asymptote is going to be whatever the function approaches as x gets really, really big. It's kind of an easy way to think about it. So I imagine to myself, if I plug in a really big number, let's say 100, I'm plugging in 100 in the numerator and the denominator. 8 times 100 is 800, plus 3 is 803. And then if I plug in 100 in the denominator, I got 200 minus 6, well, that's 194. Now, I don't know exactly what 803 over 194 is, but if I had to estimate, I'd say it's about 800 divided by 200. Well, 800 divided by about 200 is about 4. Now, the bigger number I plug in for x, the closer I'm going to get to this ratio. Eventually, the plus 3 and the minus 6 don't matter a whole lot because I got 80 million over 20 million. Well, that's 80 million over 20 million is 4. 80 bajillion over 20 bajillion equals 4. So what's going to happen is to find my horizontal asymptote, if there's an x in the numerator and denominator, I'm going to look at the ratio of the leading coefficients. Well, what's 8 over 2? Well, 8 over 2 is 4. So 4 is what this function is going to get close to as x gets really, really big. So I'm going to go ahead and draw a dotted or dashed line at y equals 4. There's my horizontal asymptote. Now from there to figure out, in my range, you'll say, okay, y values that are not equal to 4. I can get anything else I want to. Okay. Now, as far as graphing it, I know this is going to be a hyperbola. I'm going to guess that it's probably in quadrant 1 and 3. And I can check that out with a calculator to make it make sense. But if I know where the asymptotes are, I'm going to draw my branches so that they get close to the asymptotes at the ends of each branch. So it probably looks something like that. Okay. Now to check that out, if you're going to graph that on your calculator, you got to be very careful with parentheses. Okay. Clear these things out. So if I'm going to graph 8x divided by 8x plus 3 divided by 2x minus 6, I need to have parentheses around the entire numerator. Okay, very important. Divided by parentheses around the entire denominator. This is so important. People goof this up all the time. If you don't put these in parentheses, you will graph these incorrectly. Okay, it will be your fault, not your calculator's. So numerator divided by denominator. I hit graph. I'm going to zoom 6 to make sure my window works. There's one branch. There's the other branch. Now, looks kind of like the one that I drew. It's even in blue. Looks like there would be a vertical asymptote at 3. 1, 2, 3. Looks like it doesn't exist there. And for horizontal asymptote, 1, 2, 3, 4. Looks like y equals 4 would be the horizontal asymptote. Looks nice. The way I could check that, if I go to my table, And I know that, I'm going to set up my table a little differently here. We'll start at 0. So when I plug in 0, I get negative 0.5. Oh, look, when I plug in 3, I get an error. That means that's my vertical asymptote. And if I want to find my horizontal asymptote, I could just kind of scroll through some numbers. Okay? I'm over 3. If I kept going far enough, this is going to get, it's growing, but not growing real fast. Eventually, I'm going to notice it's getting really, really close to 4. Okay? That was my horizontal asymptote, and that's what it's going to be. So that's just a couple ways to look at these rational functions when it's not just a over x minus h plus k. But if I got the same degree in the numerator and the denominator, this is the way it's going to work. I'm going to use that idea for one more problem here. This internet service problem. So, internet service provider charges $50 for installation and a monthly fee of $43. Right, and graph an equation gives the average cost per month as a function of the number of months of service. And after how many months will the average cost be? $53. This is something to keep in mind when you're doing your shopping for stuff like cell phone plans, gym memberships, anything where there's like an annual or a monthly fee and they charge you some sort of installation or registration fee first. Be careful, because if you figure that into the actual cost of money, actual dollar amount you're spending, it might change your mind on how, cheap something is. So, cost function, simply how much does it cost me? Okay, total. Well, it's going to cost me to have this internet, $50 to install it, plus another $43 per month. I'll use x for months. Okay, so that's c of x, cost as a function of x. The average cost per month takes what I have spent total, okay, which would be that same function, my total amount, but then it's average per month. I'm going to take that function and divide it by the number of months, x. This is the a of x, the average cost per month. So if I were to graph this function, this is a rational function because there's an x in the denominator. I know that x equals 0 is going to be a vertical asymptote because I can't plug in 0. Well, that should make sense because it's a real life problem. I'm not going to have internet for no time. And then I know that the horizontal asymptote, because of what we just did, well, they're both x in both numerator and denominator. So if I think about this for my horizontal asymptote, 43, x over x would be 43. So I know that in time, I am going to be paying that $43 per month. But early on, it might be a little bit more expensive. So initially, after the first month, 50 plus 43 is going to be $93 divided by 1 month. We're averaging $93 a month. Use a different color. $93 a month. Okay. And the next month it'll be a little cheaper and a little cheaper, and eventually it's going to do something like this and get close to that $43 a month. That is, what you pay via your contract. Okay. Now, after how many months will it be $53? Well, I'm going to figure that out by graphing. I'm going to use Desmos because it's going to be a little bit easier. Okay. Idea is this. Here's my curve. I want to know when does it get to 53. Okay, here's 53. When do they cross? What's the amount of months that makes that happen? Okay, so in Desmos, I'll type in the two functions. Y equals, parentheses, 50 plus 43x divided by, and if you do that with parentheses, it should save that. Make sure it goes in the right spot. Okay, divided by x. Fantastic. I'm also going to graph y equals 53 because that's the average price that I want. Now, looking at this, I don't see a whole lot, but if I zoom out, should get a better picture. Okay, I'll zoom out a little more. So there's my cost curve. Don't worry about the one over here. Remember that we don't care about that. And the blue one, that would be my 53. Okay, so here's the cost here, 53. Well, where do those two things intersect? At 5. So that means after 5 months, that's when our average cost is down to $53 per month. Okay. Now, if you want to drag and follow this, notice you'd be getting closer and closer and closer. Eventually, we're getting really close to 43 the longer that it goes. Okay. So that's looking at a couple of things about rational functions, graphing them, using them, solving a word problem involving them as well.